Hello everyone, hello lovely students, welcome back to this video session. Hope you all are doing great in your life. My name is Ashwant and I'm from India, which happens to be a very awesome, wonderful country. And today I have got a really exciting math lesson for you all. Want to know what's that? Then please don't skip and make sure to stay with me all around till the end. Here we go. So we've got these two questions for today's session and we have to find the range. And I request you all to pause the video, read the questions carefully and try to solve them on your own. Alright, now let's solve these questions with me. And before we get into solving these questions, I would like to say a few basic properties for finding range of function, and some of the properties I have already covered in my previous video. So I request you once again, to those of my new students who are watching this video session for the first time, to please watch that video so that you may get a better clarity and understanding of what I'm actually talking about. Let's suppose we have an expression e of x whose range is, closed A to closed B, and we are asked to find the range of 1 upon e of x. 1 upon e of x. We have to find the range, and the range of e of x is given to you as closed A to closed B. And you all must be knowing that when we write a square bracket for the left hand boundary point and the right hand boundary point, that means they are included in the range. So for the first example that I have taken here, I have included A and B also in the range. So we have to find the range of 1 by e of x. Now what to do? Well, there are two cases. Case 1 we'll first talk about. Case 1. So in case 1, when I say e of x closed A to B closed, A and B are both positive real numbers, or A and B are both negative real numbers. So this is a very important condition in case 1, that either both the boundary points are positive reals or both the boundary points, the left one and the right one, are negative reals. So in that case, to find the range of 1 upon ex, we simply do the reciprocal of the left hand boundary point and the right hand boundary point, and we reverse their order. So for the left hand boundary point A, we do the reciprocal and we reverse it, so we get 1 by A. And for the right hand boundary point B, we do the reciprocal and we reverse the order, we get 1 by B. So this will be the range. For instance, let's suppose e of x is given as close 3 to close 7, and we have to find the range of 1 by e of x. So we simply do the reciprocal of the left hand and the right hand boundary point. So when we do the reciprocal of the right hand boundary point 7, it will be 1 by 7 and we reverse the order, so we write 1 by 7 on the left, and we do the reciprocal of the left hand boundary point. It will be 1 by 3 after reversing the order. So this is the range of 1 by e of x. Now what if the range of e of x is given as closed minus 7 to close minus 3. We have taken the same numbers, just we have made it negative. So for 1 by e of x, we do the reciprocal and reverse the order. So for negative 3, we have negative 1 by 3, and for negative 7, we have negative 1 by 7, and just we write like this way. Now just I want to make you clear that if let's say if open interval is given, what to do with that? So let's say for the same situation, if e of x were given as close 3 and open 7. Now the range of e of x, let's suppose if it were given to you as close 3 to open 7, that means in the range of e of x, the left hand boundary point 3 is the part of range, and 7, the right hand boundary point, is not the part of range, and you have to find the range of 1 by e of x. So what to do in that case? So the working rule is same, that you have to do the reciprocal of the left hand and right hand boundary points and you have to reverse the order. This time we have to take care of the open and close as well. So there is no problem. Actually, we reverse the open and close as well. So the left hand boundary point is 3 close. So it will become the right hand boundary point for the new function after doing the reciprocal. So we have 1 by 3 close. So this entire left will come on the right, and the right hand boundary point is 7 open. So after doing reciprocal, it becomes 1 by 7 open. As simple as that. Just take the negative example as well. Let's suppose E of x were given as open -7 to close -3. So -7 we have open and -3 we have closed. That means for the range of E of x, -7 is excluded. It is not the part of range of E of x, and -3 we have a square bracket or closed. So that means -3 is a part of range. Now we have to find the range of 1 by E of x. So just we'll do the reciprocal and we reverse the order, and while reversing the order of the left and right hand boundary point, we'll reverse the open and close as well. So for -3 close, when we reverse after doing reciprocal, it will be -1 by 3 close, and we have -7 open, and we'll reverse after doing the reciprocal, it will be -1 by 7 open. So this we have to do. Now let's come to case 2. So in case 2, let's talk about case 2. Let's take one example to understand case 2. Let's say the E of x is given as -3 to +7, and we have to find the range of 1 by Ex. Okay, so when we find the range of 1 by E of x, so that actually means we are doing the reciprocal of all the elements present in the range of E of x. You understand, right? 1 by E of x means what? You are doing the reciprocal of Ex. So Ex is close -3 to close 7. That means we have got infinite numbers, integral, as well as non-integral numbers starting from -3 ranging till 7. And 1 by E of x means we are doing the reciprocal of all those numbers present in the range of E of x. Just for simplicity, let's take the discrete integral values present in the range of E of x. So we have -3, we have -2, -1, 0, 1, 2, 3, 4, 5, 6 and 7. So we have taken the discrete integral values for E of x. Now for 1 by E of x, we will do the reciprocal of all these values. Let's do that. So for -3 we have -1 by 3 after reciprocal. For -2 we have -1 by 2 after reciprocal. For -1 we have -1 upon 1, which is simply 1. And for 0 we have 1 upon 0. Now this is the problem, this is the actual problem that I was trying to make you clear, and we cannot go like this. Unlike the previous case where we were simply doing the reciprocal of the left and right hand boundary point, there was no issue because in the previous case both the boundary points were either positive or negative. So 0 was not in between. But when you have the left hand boundary point negative and the right hand boundary point positive, you have 0 in between, and while doing reciprocal, 0 will create a problem because division by 0 is not defined. For the right hand positive integral numbers, we don't have any issue. We can do the reciprocal just as we did for the left hand integral numbers. But 0 is the problem. So how to resolve this problem? Well, there is a simplification. There is a solution to this problem, and the solution is we break the interval at 0. How do we do that? I'll just say it for you. Okay, so we break the interval. Oh, let me fix this for you all. Alright, so we have Ex belonging to -3 to 7. So what we do is we break the interval at 0. So when we break the interval at 0, we have -3 to 0 negative, union 0 positive to 7. And now for 1 by e of x, we follow the same working rule just as we did for the case 1, that we'll simply do the reciprocal of the left hand and the right hand boundary point, and we reverse their order while taking care of the close and the open sign for both the intervals. So for the first interval, when we follow the process of case 1, so the left hand boundary point, okay, we reverse this and do the reciprocal. So we have 1 upon 0 negative, open, and for -3 we have -1 by 3, close, union. We do follow the same working rule of case 1 for this interval as well. So for 7 we have 1 upon 7, close, and for 0 we have 1 upon 0 positive, open. Now 1 upon 0 negative is negative infinity, and -1 by 3, union 1 by 7 to positive infinity. So this is the range of 1 by e of x, when range of e of x is given to you. Now we can generalize this. How do we generalize this? Just I'll show you. So when e of x is close A to B close, where A is a negative real number and B is a positive real number, so first we break the interval at 0, so it will be A to 0 negative, union 0 positive to B. And for 1 by e of x, we do the reciprocal and reverse the boundary points along with taking care of the close and open interval. So we have negative infinity, and we have 1 upon A, union we have 1 upon B to positive infinity. Alright, so we do the reciprocal and we reverse the order of the boundary points after reciprocal. And if we have open interval, okay, just let me write so that you may not get confused. So let's say if it is open A and close B, then again same process you have to follow. A is a negative real and B is a positive real number. So again you break the interval at 0, right? And you do the reciprocal just as we did for the previous one. So we have 1 by 0 negative and 1 by A. So here both the for the left and the right hand boundary point we have open sign. Round bracket means open, they are excluded from the range. So that's why if you reverse, there's no change, but here it will make some change because we have open for the left boundary point and the close for the right hand boundary point. So after doing the reciprocal, the open and the close sign will also be reversed. So that's all. Now let's get back to the question. Let's get back to the question of today's session that we have. Okay, so the questions, yes, we have these questions for today's session. Okay. So the first question we have for our session, let's solve it. Solution of the first one. So we have 1 upon 2 minus 3 sine x, and the other concepts of range that we're going to use for solving this one I have already taught in my previous video. So I request you all once again to please watch those videos so that you may get a better clarity and understanding of what I'm actually talking about. Alright, so let's solve this. So we have 1 upon 2 minus 3 sine x. So we'll try to create this structure and eventually it will give us range. What I mean by this is you'll understand in due course of time when it's solved. So from trigonometry, we all know that the range of sine x is close -1 to close 1. That means -1 and +1, both the boundary points are included in the range. Now we multiply sine x by -3. So when we multiply sine x by -3, that means we have to multiply -3 to all the elements in the range of sin of x. So we multiply -3 to the left hand boundary point as well and to the right hand boundary point as well. It's a sign of multiplication. So whenever we multiply the range by a negative number, we reverse it. We reverse the order of the boundary points. I'll make you understand what I'm talking about. Let's suppose P is a number whose range is let's say -7 to let's say 5, and we have to find the range of -3 into P. That means we are multiplying P by a negative constant. So -3 will be multiplied to all the elements of the range. So when we multiply -3 to all the elements of the range, we multiply -3 to the least and the greatest value of the range as well. So after multiplication, the greatest value will become the least value and the least value will become the greatest value. So -3, if you multiply to so it will be 21 and it will be -15. So we reverse, like it's -15 to +21. Hope you understand. Now for the same situation, if you multiply with a positive number, it won't affect. So let's suppose if I multiply it with a 4 is a positive number. So it will be -7 into 4 and 5 into 4. So it will be -28 to 20. So if you multiply by a positive number, that won't affect, that won't reverse the order of the boundary points. But if you multiply with a negative number, it will reverse the order of the boundary points. So the left will become the right and the right will become the left after multiplication. So for this question, we multiply by -3. So when we multiply by -3, we'll have to reverse the order. So 1 into -3 and -1 into -3. So we have -3 to +3. So for -3 sin x, we have this range, -3 to +3 and square bracket from both sides. That means these boundary points are included in the range. And now we add 2. So when we add a constant number to a functional expression, so to get the range of new functional expression, we simply add that constant to the left and the right hand boundary points. So we have -1 to 5, 2 minus 3 sin x. Now our original functional expression, we have 1 upon 2 minus 3 sin x. That means we have to do the reciprocal. And just a couple of seconds back, I taught you that how to do the reciprocal of a functional expression whose left hand boundary point is negative and the right hand boundary point is positive. So for this, what we do is we break the interval at 0, right? We break the interval at 0. So 2 minus 3 sin x, -1 to 0 negative, union 0 positive to 5. Now 1 upon 2 minus 3 sin x, that means we will do the reciprocal. So when we do the reciprocal, we follow the working rule of case 2 that I have just taught you. So we do the reciprocal and we reverse the order of the boundary points. So we do the reciprocal and reverse the order of the boundary points, right? So 1 upon 0 negative, negative infinity, and it will be -1, then union. Now we do the reciprocal and reverse the order. So it is 1 by 5 and it's positive infinity. So we have the range. That's all for this question, and let's solve the second question. Second question, we have 1 upon 4 minus 7 fractional power of x. Okay, 1 upon 4 minus 7 fractional power of x. Just okay, all right. One upon 4 minus 7 fractional power of x. So we all know fractional power of x, its range is close 0 to open 1. Now multiply this fractional power of x by -7. What we are actually trying to do is we are trying to create the original expression, and that will eventually give us the range. So we multiply it with a -7. So when you multiply a given functional expression with a negative real constant number, then to get the range, you have to multiply the left hand and the right hand boundary points of the original function with the negative real number, and you have to reverse the order. So we multiply -7 to 1 and we reverse, and we multiply -7 to 0, it won't affect, and we have reversed. So after multiplication, okay, we have multiplied with -7, and here also we have multiplied with -7. This is a symbol of multiplication. Now we add 4. So when we add 4, we simply add 4 to the left hand boundary point and to the right hand boundary point. So we have -3 to 4. So 4 minus 7 in fractional power of x, the range is -3 open to 4 close. Now we have to do the reciprocal. If you observe the original expression carefully, we have to do the reciprocal, and when we do the reciprocal, we have to be careful, like because the left hand boundary point is negative and the right hand boundary point is positive. So we have to follow the working rule of case 2. Just I taught you a couple of minutes back. So I break this interval at 0. So -3 to 0 negative, union 0 positive to 4. And when I do the reciprocal, now I will follow the working rule of case 2, because for both the intervals, for the first interval both the boundary points are negative, and for the second interval both the boundary points are positive. So we follow the working rule of case 1. So for case 1 we have to just simply do the reciprocal and reverse the order, because we have already broken the interval at 0. So there is no need to worry a lot. So this will be 1 upon 0 negative, and this will be 1 upon 3. And both the boundary points we have open sign. So if you reverse the order, it won't affect. And for the second interval, it's open from 0 and it's closed from 4. So while reversing the order of the boundary points after doing the reciprocal, you have to reverse the order of the open and close as well. So yes, so we do the reciprocal of the right hand boundary point and we do the reversing. We do the reciprocal of the left hand boundary point and we do the reversing. So 1 upon 0 positive, and we have to reverse the order of open and close as well along with the numbers. So this finally comes out to be -infinity to -1/3 union 1/4 to +infinity, and that's all. So this was all about today's session, and I did my best to make you all feel comfortable and happy. If you like my video, then please share it to your friends and loved ones, and make sure to subscribe my channel and hit the bell icon to get the notification of my next upcoming video. See you all my lovely friends in my next upcoming videos with more exciting, a lot of awesome questions. Till then, bye bye, stay safe and have a nice day.